All right, what's going on, everybody? We got a day view video. We're going over derivatives. Derivatives are fundamental of calculus. They measure how a function changes as its input changes. So we can write them as d over dt or dv over dt, where dv represents a change of velocity with respect to a change in time. Other ways we can write this to sort of simplify it is change of velocity over a change in time. Formal notations are y prime, x prime, y dot, x dot, dy over dx, or the derivative of y with respect to x, dy over dt. It doesn't really matter. You're going to have to see a bunch of different notations and get familiar with them. That's just how it goes. Some simple things for us to go over are the power rule. Holy smokes, my handwriting's bad. The power rule can be notated as nx n minus 1, where n represents an exponent and x represents a variable. So some examples of this would be the function 2x cubed. The variable would be x and the exponent would be 3. We'd just multiply this by the leading coefficient and subtract the exponent by 1. We would be left with 6x squared. Another example of this we can do is 5x cubed, where we would multiply the exponent by the leading coefficient and subtract this exponent by 1. Bring your exponent down, multiply it by your leading coefficient, subtract it by 1, 15x squared. Here's some more examples. I'll write down the function, or rather the equation, 3x cubed plus 5x cubed minus 9x squared. Following our power rule, nx n minus 1, we want to multiply this exponent by this leading coefficient, subtract it by 1. 4 times 5x, 4 minus 1 minus 2 times 9x, 2 minus 1. 3 times 3 is 9. 3 minus 1 is 2. 4 times 5 is 20. 4 minus 1 is 3. 2 times 9 is 18. 2 minus 1 is 1. Typically, we don't write this. It's just understood that there's a exponent here, but for the sake of the video, I will put it there. So other examples we have are 2 plus 3x plus pi plus 3x pi minus 5x cubed. Whenever we have a constant or something not with a variable, it's just going to go to 0. So it doesn't matter. It doesn't matter. This 2 would go to 0. This 15 would go to 0. This 3 would go to 0. Whatever. 9 million, it goes to 0. If we have something, or rather a constant, with just a variable not raised to a higher power than 1, 3x, in this case 3x raised to a 1, it's just going to be itself. So this is just going to be 3. And we can prove that by subtracting this and using our power rule. We would just be left with 1x, or just x, raised to a 0 power. We understand that anything raised to a 0 power is going to be itself. 3x raised to a 0 power is just going to be 3. So this is just going to be 3. We don't have to worry about it. Pi, we can represent as 3.14 or 3. It doesn't really matter. Essentially, it's a constant. It's just going to go to 0. However, if we raise this to a pi power, it's just going to follow the same rules. As a power rule, we represent pi as 3.14. So it'll be 3.14 times 3x. You can do 3.14 minus 1. I'm just like to leave it as pi minus 1. It's a bit lazy, but I'm just going to represent it as 3 as well. It's just going to be 9x pi minus 1. And then 5x cubed, we're just going to follow our power rule. Take our exponent down, multiply by our leading coefficient, subtract by 1. So it'll be 15x squared. Let me make this look a bit nicer. So we're going to have 0 plus 3 plus 0 plus, let's go, pi times 3, x pi minus 1 minus 3 times 5x, 3 minus 1. This will be 3 plus 9, x pi minus 1 minus 15x squared. Some other examples are if we are dealing with a negative exponent, for example, 2x to a negative 2, 3x raised to a negative 3, plus 5x minus 2 plus 3x to a negative 3. We're just going to follow our power rule. It's just going to be a bit different. Negative 2 minus 1 plus negative 3, 3x minus 1 plus negative 2, 5x. You don't have to write this every time, just until it becomes intuitive to you or a second hand. I would highly suggest it. There's going to be a point where you get so good at this or it becomes so familiar with you that you're just going to start doing it in your head. excuse me, we have negative 2 times 2, which is negative 4, x. Negative 2 minus 1 is negative 3. Negative 3 times a positive 3 is negative 9, x. Negative 3 minus 1 is negative 4. We have negative 2 times 5 is negative 10, x minus 3, plus minus negative 9, x minus 4. This is a fine way to write it. Another way we can write it is we can put this leading coefficient on top and then write this x cubed under as a positive rather. It's going to be negative 9x cubed to a fourth power plus negative 10x cubed plus negative 9x, sorry, negative 9x to a 4. So essentially, we just want to have our leading coefficient on top, and then we want to put our variable with our exponent as a positive below. So either way works. This is probably the best way because it'll become more familiar when you get into integrals, which is further along in the course. I wouldn't really worry about it now. Some other things we can work on are fractions. So we have 3x raised to a fourth plus 4x raised to a third plus 2x raised to a half. Sorry, 2x raised to a half plus the constant 3. Want to follow our power rule, which once again is exponent multiplied by a variable minus 1. So this would be a fourth times 3x raised to a fourth minus 1. Remember, when we are subtracting fractions, we essentially write this one as the same as the denominator. So 1/4 minus 1 would be the same as 1/4 minus 4 over 4. Same thing with third, it'd be 1/3 minus 3 over 3. Then a half would be 1/2 minus 2 over 2. So we would be left with the expression 1/4 3x 1/4 minus 4 over 4 plus 4x cubed, sorry, 1/3 minus 3/3 plus 1/2 2x 1/2 minus 2 over 2. And then this is just going to go to 0. It's just a constant. So we're going to be left with 3/4 x. 1/4 minus 4/4 is going to be negative 3/4. 1/3 times 4x is going to be 4/3 x. 1/3 minus 3/3 is going to be a negative 2/3. 1/2 times 2 is going to be just x or 1. There's no need to write this. I will write it for the purpose of the video. And 1/2 minus 2 over 2, or as some people like to call it, a fancy 1, will be a negative 1/2. And as I had mentioned earlier, there's a better way to write this: 3/4 over x to a 3/4 power. So you want to write this variable below and then turn this negative exponent into a positive. 4/3 x over 2/3, sorry, 4/3 over x to a 2/3 plus x over, or sorry, 1 over x to a half power. Now, this is a bit weird and informal because we have fractions over fractions, but it's just another way to write it. You can simplify it and write it however you want.